Okay, welcome to week 3. In the previous video, we imported our 2D art and built a level using tile maps. Our player can already move and jump, but so far the character looks pretty static. In this video, we are going to bring the character to life with animation, and we will set up 4 movements animations: idle, run, jump, and fall, plus a hit animation for when the player takes damage. And then we will connect them to our player scripts so the animator automatically switches states based on the character's movement. At the end, we will also add a smooth camera follow scripts so the camera tracks the player across the level. And let's start by create our animation clips from the spreadsheet. So in our project window, I will locate the spread frames for our character. Uh, so in my case, it's in the mask dude. Uh, the set pack gives us separate frames for idle, running, and jumping and falling. Uh, so first, I will give you an example. We need uh, we need choose the window and animation. So we click in hierarchy on our character. So we can see the create new clip, and now we create a new one and name the 111. So for example, I will make a idle animation. So we take this and select them and drag them into um, and drag them into the animation panel. So our first animation is complete. So the other animation is same as it. So to save time, I have finished uh, 5 animations we need. Now we deleted it. And after we finish these 5 animations, we need to create a animator. This one, animator controller, and we name it character, and we have created. So uh, to drive these animations, uh, so then we need open the animator window from the uh, so we need this animator window, so we can click we can double click our animator we made, and we can see this one. And this is where we will build the state machine that connects all 5 animations. So our 5 clips is already in here. So next, we will add the parameters that our scripts will control. So in the parameter lib, uh, you can see we have 4 parameters. The first one is speed. It's a float, and the float it's named y velocity. Yeah, you can add the parameter in this. And another parameter is a bool named is grounded. And the next one is a trigger named hurt trigger. So it's very important that these names match the strings used in our C# scripts exactly. Same spelling and the uh, capitalization. And otherwise, the animator won't receive the correct values. And now we set up the transition between the states. So the first is from the idle to the run. And you can make the transition and click this line. You can add some conditions. And from run by idle, we also have 2 conditions. We can see other lines. The hit, it has no conditions. And the idle to jump, and the run to jump, and fall to idle, and jump to fall, and fall to run. And the any state to hit, it's a hurt trigger. Okay, when we finish that, now let's look at the scripts and drives all of this. And then we need to back to our scripts folder and the player controller. And we can find our scripts in the Google Drive and this one. And we select all and copy that and paste in here. Okay, so at the top, we require a rigid body 2D, an animator, and a script render, and which are exactly the components we have on the player. And under move, uh, we have the move speed, acceleration, and the deceleration. And instead of the instantly snapping to full speed, we need smoothly accelerate and decelerate, which feels better for the platformer. And under jump, we have jump force plus the coil time and the jump buffer time. And the coil time means the player is still allowed to jump for a short moment after leaving a platform. And jump buffering means if the player presses jump just a bit too early, the game will remember it for a short time and still perform the jump when it becomes possible. And both of these features make the controls feel more forgiving. And we also have a ground shake section. This ground shake transform is a small point at the player's feet. So in update, we call physics 2D. And in the main update loop, as long as the player is not hurt, we read horizontal input with input get access row horizontal and compute a target speed. We flip the speed by checking if the input is negative. If so, the If so, the SR flip X is set to true, and we also handle the jump buffer when the player presses the jump button. And when the buffer jump and the correct timers are both positive, we actually trigger the jump by setting the rigid body vertical velocity to jump walls. And we also support short hopping. If the player releases the jump button while moving upward, we cut the vertical velocity in half to make a lower jump. And at the end of update, we send three values into animator. Speed is absolutely horizontal speed, and y velocity is the current vertical velocity. Its grounded tells the animator whether the player in on the ground, and this matches the parameters we created earlier. So the animator can choose between idle and jump and fall. And in the fixed update, if the player is not hurt, we smoothly move the rigid body's x velocity toward target speed using the max f and max f smooth move towards with different acceleration depending on whether we are starting or stopping. So finally, we have a hurt method. And once this script is attached and the reference are set in the inspector, and the animator will receive live data every frame and automatically switch between idle, run, jump, and hit. And now we save it and back to Unity. And now we can test it. Oh, one thing. And now to make the camera follow the player smoothly, we use a separate script called the smooth camera follow. Uh, you also can find the scripts in the Google Drive. This one, and you can create a script. So in the code, we first store the camera's original Z position, act, act, uh, so we don't move it and out of the screen. So each frame in the late update, we compute the third pulse based on the target position plus the offside. And then we use the vector 3 lerp to move from the current position to that desired position over time, and which gives us the smooth following effect. And if you use bound, if use bound is enabled, we click the camera's X and Y inside the mean position and max position. So the camera never shows empty space outside the level, and the drive method uh, draws a green box in the scenes view, and so we can see the bonds visually when the camera is selected. With this in place, so we can back to the Unity and oh, uh, remember to drag this scripts to the inspector. So you can see we also add this script. And now when we press the play, and the camera gently follows the player as they move and jump through the level. And you can see jump, jump, jump. You can see the main camera is following the player smoothly using our smooth camera follow scripts, so we can move across a larger level without the player ever leaving the screen. And that's everything for this video. We now have a fully animated character with a smooth movement and a camera that tracks them across the level. And in the next week, we will add some UI and scoring and win lose conditions to turn this into a complete mini game. So see you next week.